So in the last session, we have discussed about the cathode, what takes place, anode, what takes place. So suppose if the cell reaction is given like, let's take copper. Yeah, let's take copper plus silver ions giving copper 2 plus and silver. Suppose if this is the cell reaction given, we have to identify what the cathode and anode respectively. In the Daniel cell, copper was my what cathode, but in this particular cell reaction, what is my cathode? My cathode is silver. So first thing I'll write here at cathode. So again, the examination point of view, you write like this. Cathode, what will happen? Reduction. Correct? It will be what? The silver. Yes, the silver ions will be giving what? 2 Ag. It is an accepting electrons at anode. At anode, what happens? Oxidation. Here, copper is giving away the electron. In the sense, Cu, the metal gives metal plus electrons respectively. So cell representation, suppose if you want to represent this whole thing, cell representation. Yes, so this I can write as what? Copper bar Cu 2 plus and salt bridge gives Ag plus and Ag. This is my cell representation. In the sense, here what the anode should come first. Yes, the anode and its ion, then cathode and its cathode ion and the cathode respectively here, cathode electrode or the metal respectively. Suppose, and last class we studied about what standard electrode potential. So let's take the E cell. E cell is basically what? E cathode minus E anode. So here it should be what? What it should be here? It should be E. My cathode is here silver. Ag plus bar Ag minus anode. Anode is copper here. ECu bar Cu2 plus. So this is a very simple what reaction. Okay. Then the next topic is standard hydrogen electrode. SHE. She. Standard hydrogen electrode. So the diagram I'm not drawing here. Okay. So basically what it is nothing but the hydronium ion. Correct? Yes. Plus electron will give me what? The hydrogen atom. This is my full reaction for this. This is the only reaction available for this. H plus plus E minus gives half H2. And the standard electrode potential, since this has only got one thing, correct, I can write clearly what? E, H plus bar, H2, H plus bar, H2, this value is 0. I'll write here the standard electrode potential for the hydrogen cell is 0 because E cathode and E anode is almost equal only. So this is my standard hydrogen electrode. But the important thing is this one. In cathode, reduction happens, that is it accepts electron. Anode, it gives away the electron. The metal gives away the electron. So this is the same concept which we'll be using in Nernst equation, which is very important. The most important thing in this is Nernst. NER NST. Okay, that is my Nernst equation in this. Fine. So Nernst equation, the same thing only I'm using. Metal. Metal gives what? Iron plus electron, Ne minus. And in problems, we'll be using this N. number of electrons, this is there, right? Correct. This will be using in problem for n. So what is the purpose of this Nernst equation? So I'll write down here what is the purpose. Yes, it is to calculate the electrode potential at any concentration. So the important thing I'll underline here, concentration here. So now basically what I'm going to write is this only. Here I written A E Ag plus bar Ag, right? Similarly, I'll write here E instead of Ag plus bar Ag, the cathode, I'll write on here Mn plus bar, or else let me just erase this. Yeah. E, then metal, Mn plus bar metal. Yes, this is equal to what? The standard electrode potential of this. The standard electrode potential. How do I identify standard electrode potential? By the zero symbol, E naught symbol. That's it. Yes, E Mn plus bar M. This is my Nernst equation. Okay, by minus RT by NF. This is my N value, NF Ln. Okay, the ln of metal by Mn plus. So the square bracket, again I'll write down here. The square bracket indicates concentration. Yes, so this is of what? What is this thing? This is concentration of this metal with the concentration of this metal ions. So this Ln is this by this. Okay, just like the log, here it is what? Ln, that's it. The log, we calculate the log, right? It's same as Ln only. Okay, so log will be to the base 10, Ln will be to the base E. Fine, so that I'll be helping you out. Okay, so this is the basic formula for the what? The Nernst equation. First point, E metal, this is N plus bar M is equal to standard electrode potential of this particular thing, electrode potential of this metal, whatever it may be, minus RT by NF, Ln of M by Mn plus. So I'll explain you what is this R. R is my universal gas constant. I'll write down here. Universal gas constant, that is 8.314 kilojoule, or else let's leave out the unit here, 8.314 F Faraday's constant, 96,500 coulomb per mole, that is. Okay, so if you want me to write the unit, I'll write down here. This is joule, Kelvin minus mole per minus what? Okay. And now this Mn plus, this Mn plus is nothing but what? The concentration. Whenever it is in square bracket, it represents the concentration. So concentration of that particular metal species. Okay, and temperature is always 298 Kelvin. Yes, and what is this N? N is nothing but, I told you what it is. For example, if I take this thing, the N is what? I'll circle it around here. I'll circle it around. This is my, this is not the N. The 2 electrons is there, right? To balance the thing. This is my N respectively. It can be 1, 2, or 3. Okay, so number of moles of electron. So number of moles of electron, yes, indicated in the balanced equation. Very important is this N, because problems will be based on this N. So we should not be blank why this came. So if I substitute R value, if I substitute F value, if I substitute temperature value in this equation, this particular equation, this equation will become as follows. This is a final equation where we have to study it. E Mn plus bar M is equal to what? E naught of Mn plus bar M plus 0.059 by N. ln of Mn plus. Okay, so you can ask me few doubts in this. One of the doubt is what happened to this M? This M, and how did the minus became plus? Minus became plus in the sense I took this Mn plus to the top, and the concentration of this metal is unity. Concentration of this metal is what? Unity. So directly I substituted here. So minus became plus because I took Mn plus to the top. So this is my final equation in this. So the only thing in this is we have to by heart this formula, and we have to know what are all these things. N is number of moles of electron. This is the important thing in this. So these things directly will be using in the formula. And in the last session we have done about what? The Daniell cell, right? Correct. So I'll write down the Daniell cell here. Let's apply Daniell cell. Then I think you will be able to recollect it. So I'll write on Daniell cell first. Zinc, yes, the anode. Zinc and Zn2 plus. Then the salt bridge. Correct. What is the purpose of salt bridge? For the conductivity. Yes. So first I'm writing the anode, then the cathode. In the Daniell cell, the anode is zinc, cathode is copper. How will I write for this particular thing, the Nernst equation for this? Same thing. E cell is equal to what? E node cell, the standard electrode potential of the cell, plus 0.059. Yes. And log of ln is nothing but log. Correct. Log of what? Log of cathode by anode. The cathode is here Cu2 plus. The concentration by what? Zn2 plus. This is what I would write here. And the most important thing is by N. N is what? 2 electrons, because Zn gives Zn2 plus plus 2e minus. I'll write down here zinc Zn2 plus plus 2e minus. This 2 only I'm writing it as what? N. This N is nothing but this 2. That's it. Okay, in the balanced chemical equation. Okay, this is the first one in this. Molar conductivity. Yes. So what is this molar conductivity? Obviously, it is a conductivity of a solution, yes, of an electrolyte divided by the molar concentration of the electrolyte. So if I tell you like this, we won't understand. So better, I will show you through this. It is represented by this symbol. Okay. This is my molar conductivity symbol. I'll write here as what? K by C. Okay. Or else I'll further simplify and write it as what? K into 1000 by molarity. Now I will write down the definition for this. The one which I just spoke about right now, right? That same thing. So what is the definition I told here? I'll come to the video and I'll tell you. So what is the definition I told here? So molar conductivity is nothing but what? It is a conductivity solution of electrolyte divided by the molar concentration of the electrolyte. So that the efficiency which is electrolyte with the electrolyte conducts electricity in a solution. But if I speak like this, we won't be able to understand. Correct? Yeah. So that is nothing but a definition. So that I will write it down. Simple, in simple thing. This symbol is what? The molar conductivity. So it is basically what? Conductivity of solution of an electrolyte. So this K is nothing but what? Conductivity of the solution of an electrolyte, correct, divided by the molar concentration of the electrolyte. Conductivity to what? The molar concentration of the electrolyte. What is the purpose of this? So everything we have to know the purpose. Yes. So what is the purpose of the electrolyte? The main purpose of electrolyte is to what? To conduct electricity in the solution. That's it. Or else, suppose if you're having a doubt between, okay, molar conductivity is there, and what is this conductivity? See, conductivity also we use the term. Yes, conductivity is nothing but it is conductance per unit volume. Conductance per unit volume of the solution. But if you ask me what is this molar conductivity, I'll write down here. So that is also a conductivity. Yes, this is conductance per unit volume solution. This is nothing but conductance of the entire solution. The entire solution having 1 mole of electrolyte dissolved in it. 1 mole of electrolyte dissolved in it. So these things you cannot get in your textbook. Okay. So I just explained what is conductivity, what is molar conductivity. Fine. Okay, fine. Then there is something called, this is molar conductivity. Next thing is limiting molar conductivity. I'll write down here. Next thing, limiting molar conductivity. See, when the concentration, yes, or else I can say the molar conductivity of a solution, yes, whose concentration approaches zero is called limiting molar conductivity. So what is this actually? It is nothing but the molar conductivity of a solution. The molar conductivity of a solution whose concentration approaches zero. Yes, this is nothing but my limiting molar conductivity. Okay, this is a symbol, same thing you write, but you put a not symbol on top. So this is nothing but my limiting molar conductivity. Fine guys, up to this. Is everyone clear about this, or is it kind of tricky? So it's a very easy topic to remember things. So again, problems only will be using this. Molar conductivity and limiting molar conductivity. Molar conductivity is nothing but what conductance of the entire solution having 1 mole of electrolyte dissolved in it. But conductivity in generally is per unit volume of the solution. So when the molar conductivity of a solution approaches zero, it is called limiting molar conductivity respectively. That's all.